So we randomly assign folks into small classes and regular classes, right? And as a test for the randomization, we wanted to see, are the teacher characteristics and the student characteristics similar in both types of classes? Because if we see that the teacher characteristics and the student characteristics are similar in both types of classes, then that would be a showing test that the randomization was done properly, right? Does that make sense? Okay. And so what I said was, the way to check that is we take a dummy for like a teacher characteristic or a student characteristic, so for example, female, and we regress that on some constant alpha 0 plus beta times this indicator small ij. And you can just look at this, I just want to explain this to you conceptually. Plus an error term, right? And so what this is saying is, and so if we look at the expected value of this equation, this is like, what's the probability of being a female if you're assigned to a small class? And so when we get that, that's going to be alpha 0 plus beta times 1, right? And the expectation of this error term is going to be 0. So that's just alpha 0 plus beta. So this is the probability of females. This is the probability of being a female given that you're assigned to a small class. Does everybody understand that? And then if we look at what's the probability of female conditional on being assigned to a large class, it's just going to be alpha 0. And so the difference between these two is going to be just beta. And so beta is going to represent how much more likely is it that a female is assigned to a small class versus a large class. And if the beta is significant, then what that's going to suggest is that females, if it's positive and significant, that females were more likely to be assigned to the small class rather than the regular class. If the beta is negative, it's going to be the opposite. If the beta is statistically indistinguishable from 0, that's going to suggest that we do have random, that based on the characteristics of, the observable characteristics of the students, that there seems to be random assignment. Does that make sense? Any questions on that? Okay, good. All right. So, we're going to talk about economics. I'm going to raise So the way to think about hedonics, so what we've looked at is we've looked at, well, what's the relationship between an input like class size on test scores, right? And when we think about hedonics, like in particular in the context of education, what we're going to say is how much are households willing to pay for better quality schools, right? So we can think about the relationship between these two questions as, okay, here are the inputs that drive better schools drive better outcomes, but since better schools drive better outcomes, there should be a market for better schools. And then how do we find out what are the prices for better schools in this market? And the way that we do it is, so let's use a definition. So hedonic approaches are a way of valuing a non-market amenity by looking at how much people are willing to pay for them through revealed preference. And by revealed preference, what we simply mean is the following. You have option A and option B. You choose option A over option B. So by revealed preference, you prefer option A to option B. So in the context of our example, what we're going to be looking at is the following regression. the economic regression
Value.
model. Okay, so given a house I in neighborhood capital N, we're going to say the log of price of house I in neighborhood N. There's going to be some alpha, which is just going to measure like the average value of house N, plus beta times the test scores in neighborhood N. And so neighborhood N is going to have like schools in that particular zone, right? And so you can think about this as a measure of the school quality. Plus beta HIN, where the HIN are going to be characteristics of the house. So these are going to capture how good is the housing. Plus kappa CIN, this is going to be characteristics of the neighbors. Are your neighbors noisy? Are they other well-educated folks? Are they okay? Now here's the problem, right? If we have neighborhood and 1, right? And we have neighborhood and 2. And let's say they have 2 different school zones, right? If we just compare test scores in this neighborhood to test scores in that neighborhood, these neighborhoods could also have like very different types of people. And so the idea on very different types of houses is going to be to focus on this boundary area here. And in this boundary area here, the assumption is going to be that the house characteristics are the same. The type of people are going to be the same as well too. And then we can look at differences in the house prices across between houses on one side of the boundary versus another side of the boundary, right? And how that is going to be related to differences in house prices. So that's the idea. And so you can see that in this first slide here. So in the top left-hand corner here. So we have 2 school attendance zones, school zone A and school zone B. And school zone A is going to be the better school attendance zone. So this is going to be the school attendance zone that has higher test scores. And we're going to think about higher test scores as being high quality, right? And when we look at the second panel, this is going to show us how the characteristics of the house are going to differ across that boundary. So take, for example, the topmost graph in the, so this is top right-hand corner. Let's look at, on the horizontal axis is going to be distance to the boundary. On the vertical axis are going to be house characteristics, like is it owner-occupied housing, or the number of rooms, or what time was it built. And you can see as we go from the left side of the boundary to the right side of the boundary, the housing characteristics seem pretty continuous, right? There's no big jump in the housing characteristics. But if we go to this graph of test scores and housing, what we see conversely is that as we go from the left side of the boundary to the right side of the boundary, test scores goes up by a lot. And so the school attendance zones are going to be very different in terms of their quality. Does everybody see that? Now when we look at prices, we also see that prices are going to be going up discontinuously across that boundary as well too. Does that make sense? And so what this is suggesting to us is that as we go across the boundary, the characteristics of the houses are going to be very similar. The types of people that are living in the houses are going to be very similar too, but the quality of the schools that the students have access to are going to be very dissimilar. And moreover, the prices that households are paying are going to be very similar too. And so we can get at how much more somebody willing to pay for it, how much more somebody willing to pay for the test scores, because that's going to be capitalized in the price of the houses. I.e. the houses are more expensive in the better school zone because the better school zone has better schools. Not because the houses are different, not because the people in the houses are different. That's the only thing that's going to be changing discontinuously across the boundary and exactly at that boundary. Right? And if we look at these regression results here, so in the first column, what we do is we regress what's the cost of the housing on average test scores and also demographic characteristics of the neighborhood. And this is for like a really large sample where we don't include, we don't control the whether we're looking at a boundary sample or not. And what we see is that there's a huge effect of average test scores on housing. There's a huge effect of average test scores on housing, which would suggest that people care a lot about average test scores. But when we control for these boundary fixed effects by only focusing in on the houses that are close to the boundary, what we see is that the effect of test scores goes down from like about $123 to about $33. And what this is saying is that if we looked at all of the households in this neighborhood, right, effectively, the people on average who are in the better school zone are also different in other categories. They're more college educated, you have a higher fraction of whites, et cetera, et cetera. But when we focus in only on this boundary area, we're controlling for those demographic differences that can be driving differences in the test scores as well. And so this is another way of taking care of endogyny. So I'll just leave it at that. You guys have a great weekend. And see you in class on Tuesday. You can come up to me.
The beta test N, would the test be IN, like sub, the other one?
Taking notes in my text is the best thing that I have.
It would, it's like both.
So we can